Hello, my name is Cornelius Kölbel. Thanks for coming and showing your interest. I'm going to talk today about two-factor authentication. And two-factor authentication, no need for Gemalto. This is to show you that you do not need to trust in any big proprietary company, but as the title says and suggests, you can do it yourself. And well, the image I chose may be a bit misleading because I think it's not that complicated. You will not put the hammer on your thumb or something like this, but we will see now. So, who of you has any experience with two-factor authentication? Okay, that's good. So I think you know all the basics. Well, then let's first talk about control. I have a picture here. It's a cockpit of the, I think, last space shuttle of the Endeavour, and everyone likes to be in control. And hey, what's this? If I look at this, I don't have the feeling that I'm in control. I'm confused. I'm overwhelmed. I don't know anything. Well, I think many of you also heard the previous talk. So if I'm talking of authentication, we all do it usually, I know, me too, often with passwords, because several services do not allow to do anything else. But now we learned what we have to do to use good passwords. That's great, but nevertheless, it's still a decent attack to just use some binoculars and or I came here by train, in the ICE train, and if I sit in my row, I can look in the row in front of me, and or the guy behind me can look in the row in front of him and see my password. So that's bad. And even there are certain guys that feel a bit unsecure because surveillance is increasing if I'm going with a train, or, well, the small train that goes through town, or in a bus. Everything is surveilled nowadays, and of course we cannot be sure if the surveillance camera also fetches my password when I'm logging into my computer or to my mobile phone or whatever. So, what's the status at the moment? What's about control? Yeah, here, out there to the left, there's the booth of the FSFE, and they have this cool bag. Yeah, we are using other people's computer, so our data is somewhere else, and if the data is on the move, it is sniffed, our emails are read, and so on. And as far as other people's data is concerned, the established two-factor authentication companies, for example, start to provide authentication services, which means I run or I rent a computer, not even my own computer, I just rent a service, and this service will validate my two factors, which means I set up my system, and then I say to my system, maybe my firewall, my VPN or whatever, hey, over there's this service from the great company, and just send the credentials to the service, and this service will check if they are valid. To me, this sounds a bit unpleasant, relying on a third party to decide if someone can authenticate, can get access to my data, or can come into my network. And then, I think we all know the old story of RSA. They have, most companies, if you're talking of one-time password tokens, you have the problem with the key material. So are you familiar with one-time passwords, roughly? So you have a symmetric key, and this symmetric key is used to create a seemingly random password. And if the user is able to provide the right password to the system, then we can deduce, oh, if the user was able to provide the right password, then obviously he must be in possession of this device, because this device has the secret key, and only with the secret key I can generate these passwords. And well, most of those devices are preseeded, which means the vendor of the devices generated the keys, put them on the device, and also gave me a file with all the keys in it. So the problem is, of course, I'm wondering, okay, I just got this file, okay, at least maybe in an encrypted email, but where are still copies of this file? I cannot know this. So it's a big topic of the key material here. Then there are vendors who are using proprietary algorithms, so we do not know how certain vendors generate these one-time passwords. The software they are using have unknown workflows or side effects. And of course, I don't get the source code. I cannot know what the software in detail does. So to sum it up, I think at the moment this would be a total loss of control. Just like the captain of this boat lost control and ended up on the beach. Okay, this is a very nice beach and the sun is shining and everything seems fine, but I think we don't want to end up on the beach here. I think we rather get back into the driver's seat and we try to regain control and get rid of all this mess we just saw. So, what would be our goal? Our goal would be to use our own computer, to use our own hardware under our own control, so that we can protect our data and we can protect the decision if an authentication request is sent, that we can control the hardware, we control the software, so that we have the control over the decision for the authentication request. Then, in a perfect world, we would create our own key material so that we know, okay, I have cryptographic keys, but I generated them on my own. I know there are no copies of these keys anywhere in the world, anywhere at my reseller, at the distributor, or at the vendor. Then, of course, we like to use open algorithms that are standardized. And if we do so, we should have well-documented protocols and API that we can talk to a system that is doing our authentication requests. And of course, this is to be open source. And yeah, I will come back to this requirements here. You said you are all you have experience with two-factor authentication. I just want to point out one thing again. Two-factor authentication always combines two of these known factors of knowledge, of possession, or of an attribute. We know this as a biometric attribute. Today, the knowledge is the password that we are typing in, but in my opinion, it could also be something else. But I think there are, maybe you see it also in the press, there are big discussions about, oh, passwords are evil and so on and so on. I don't think so. I wouldn't sign this. Passwords are not evil. And if I step a step back, knowledge, I think, is a very interesting and very important factor to authenticate. And in all this PR effort that we see today, I think this bashing on the password drops this very good factor of knowledge. The biometric attribute, which is also very en vogue today, because all our smartphones have these fingerprint readers and so on. And I also heard from a science congress, they were researching the gait recognition so that the acceleration sensors in my smartphones would identify my gait, the way I'm walking, and if the sensors and the software then realize, these are the parameters like Cornelius is walking, then I can unlock the smartphone screen. Cool, but
then you hurt your leg.
Pardon?
Then you hurt your leg.
Yeah, then I hurt my leg, that's right. This is, of course, this is one problem with the biometrics, but have I shaved, have I glasses, have I grown a beard or whatever? But I think there's another very interesting thing to think about, because if a user tries to log in to a machine, in more detail, if an employee tries to log in into a machine, is it important for the machine that it's really me, Cornelius Kölbel, born somewhere, raised, and whatever? Or the other way around, is it for me as a person maybe important that not I as a person need to identify to log into the machine? So what I want to point out is that there is a difference between my user account and authentication objects I use to prove that I'm the owner of the user account, and there's a difference between to me as the person, as an identity. Yes, if I broke my leg, but also I think the employee thing is a very interesting thing, because one day when I'm the employee, and one day I leave the company. So I, as an employee, do not want my employer to have information about my person that cannot be deleted. If I leave the company, or if I think my password is compromised, or if I lost my smart card or whatever, I can call the IT help desk and I can change my password. I can revoke a certificate. But have you ever tried to revoke your fingerprint? You can do it. 9 times. And I think that's the problem with the biometrics authentication. And also the question is, do you really have control over your biometrics? Do you have control over your fingerprint or over your face? And this is why I like to differentiate between a user account and a real human identity. And this is why I do not look at biometrics authentication mechanisms here. And so there remain the 2 factors, knowledge and possession. And so I can look at the possession factor. Possession factors, I think it was invented 1986 by RSA with this terrible proprietary thing. And there are several different authentication factors. In the upper left there's a smart card. You have one-time password tokens as a hardware, as a classical hardware, as a key fob that goes to your key ring. You have this in the lower left corner, the YubiKey, which you probably might know because they are doing a very good marketing. Who does not know the YubiKey? Okay, the YubiKey also can do many things, but it also emits a one-time password. You connect it to the computer and it works as a keyboard. And if you press this button, it emits the one-time password. So the classical one-time password tokens display it, the one-time password, and you have to type it, and this one can emit it. Yeah, then you have the big world of all the smartphone apps, like the classical Google Authenticator and all new stuff. And yeah, you also have your, honestly I don't know how it's in the Netherlands, but you also have your ID card, your personal ID card from the government that was issued from the government. And you could also, if you wish to and like to, use it to authenticate somewhere if someone supports this. So how do these possession factors differ? A very important thing, if you look at the possession factor, is the uniqueness of the factor. I already said this, when you get these tokens and you get this file that contain the secret keys. And of course, if the vendor or the distributor copied the secret keys or keeps a copy of this file, the secret key that is used to generate this one-time password is not unique anymore. So this is why I differentiate between preseeded and seedable devices. So, and the interesting thing is that even my public ID card is a preseeded device because the key material is written on the device by the, in Germany, by the Bundesdruckerei. And I do not know how the key material was written on the device and if it's, how many copies exist. Because if I look at a smart card, I can generate the key material on the device, then I know that the private key will never leave the device, but I also can generate the key material outside of the device and then import it into the device. And of course, most of the hardware key fob tokens are also preseeded. And but we also said, oh no, we want to have control over our key material. And this is why it's interesting to take a look at the seedable devices. Somehow the smartphone applications like the Google Authenticator are of course also a seedable device because I can create my key and then import it to the smartphone app. So from this standpoint, I could say, yeah, it's a seedable device and I have done something for the uniqueness of my key. No vendor knows the key. Google, I'm using the Google Authenticator, but Google does not know the key because I generated and I scanned this QR code and imported it. But the question, of course, is how good do you trust the security of your smartphone? Then the most interesting things are in the lower right corner. These are the seedable hardware devices, which means you have a hardware device and you can write the key material. You can create the key material yourself and write it on this hardware device, which means no vendor has sent you key material. It's your own key material. And the key material is rather safe because it is stored in a hardware device that is safer as a software device. Okay, we could talk about side channel attacks or whatever, but the point is, imagine I have two authentication devices. A hardware device and my smartphone. In both devices, there's this key that is used to generate the one-time passwords that I use to authenticate. Oh, I have to go to the toilet, very important. I run to the toilet. Then I come back. 5 minutes later. There's my hardware device and there's my smartphone. It's my personal opinion. I think if the hardware device is still there or again there, and there are no scratches or other marks on the device, I can be relatively sure that the secret key was not tampered with, was not compromised. My smartphone, after 5 minutes, I don't know what happened to my smartphone. If someone took it and somehow read the memory or whatever. So this is why this is a point I think where that has to be clear. You can of course use a smartphone as a second factor. If you are using these cool passwords and add a second factor with a smartphone, you can do nothing wrong. You are not worse, or you are not. You are not worse than before. So, of course, you also increase security when using a smartphone. But the question is how much you increase security. And if you say, okay, I use a second factor, a smartphone as a second factor, and now I have my second factor, and because of this I decrease my password strength, maybe overall, then you have decreased your overall security. Okay, now we saw that there are many different types of second factors that can be used for authentication. What now? I want to talk about an open source solution, privacyIDEA, which is able to manage all these factors and to act as a central authentication system. So on the right side you see some users, and these users can be located anywhere. privacyIDEA can read these users from the existing user sources like your LDAP system or an SQL database. Then you assign tokens or enroll authentication devices to the users, and you can configure all your services, your local authentication or your VPN against this system. So, as said, it manages your second factor, And to use this image, it puts you back in the driver's seat, because in your network you can say, okay, I install this machine and I install privacyIDEA, and I can be sure that all my authentication decisions, all my key material, everything is under my control. It is open source, and it uses algorithms that are defined in the RFC. It is well documented. You can find the complete documentation on Read the Docs. And I think it's still rather lean, because it comes with only 15,000 lines of code, of Python code. So if anyone ever wants to take a look at it, I think it's not impossible. So regarding the architecture, it's written in Python and uses Flask as framework. And all the token information and assignment to which token is assigned to which user, and policies and configuration, is everything stored in a SQL database. You can use any SQL database you want to, because it's in the SQL alchemy, it's a SQL wrapper is used, so you can usually run it with MySQL, MariaDB, or Postgres, or whatever. So the development is rather dynamic. Here is an excerpt of some things that happened during this year, and there are also some special things, like, for example, to use one-time passwords in an offline mode, or to use the YubiKey to boot your notebook. So if you have an LUKS encrypted notebook, you can configure it this way, that you have also to use the YubiKey, that you can boot it. So you have two factors in this pre-boot phase. You have to enter a passphrase, and you have to have the YubiKey. The latest new stuff that came along was this U2F thing. Okay, I guess there are some guys who don't know what U2F is. It's U2F, it's a universal second factor. It's a protocol that is designed by, in the lead by Google and others, and other companies that have huge end-user bases. Let's take it this way. And the idea is that you have a hardware device that which you can use to register with any service, with any web service, and then you can authenticate with this device to this service. And the very interesting idea is that you do not have to have a device for each service, because you are only using one device for Google, for eBay, for whatever. And the other interesting thing is that there is no central management authority, which is very interesting for the end user. And this is why I think U2F is a device originally designed for end users. So if I register my device with Google and I register my device with Amazon, Amazon does not know that I registered my device with Google, and Google does not know that I registered the device with Amazon. And that's rather cool, but yeah. Okay, now I'd like to show you some things. While I'm preparing some things here, you can think about if you have any questions in the meantime. No, okay.
Do you know, are there different hardware-wise YubiKeys? I think there are the Neo and another one, right? So what is the difference?
Yeah, that's right. There are many different YubiKey devices, or there are many different functions that are provided by the YubiKey devices. There are the classical one-time password functions, so it is recognized as a keyboard, and it emits a dynamic one-time password. There are two different modes, but don't matter. Then it can act as a keyboard and emit a static password, and it can act as a PGP smart card. You can put your PGP keys on it. Then it's getting a bit more difficult, because you have to start and take care about drivers. All the OTP stuff, the nice thing about this, it's driverless. And then there's this functionality with this U2F. So, there are these 4 or 5 functionalities. Yeah.
So which one, you have considered this? Well, which one you think is the most best fitting in your philosophy?
Which the best fitting is? It totally depends on your scenario. I was, if I'm an end user,
you painted.
If I'm an end user, I probably would go for U2F, because then I can go and authenticate at third-party services. If I'm a company, or I would, if I'm an ambitious end user who is also doing development and hacking, then I would go for the device with the PGP smart card support. If I'm a company, it's a bit difficult, because, in my opinion, I was working with smart cards about 10-11 years ago a lot, and if you have a large user base, installing and distributing drivers is always a pain. And this is why, in a company environment, this OTP thing is still a very cool stuff, because you can just enroll it and give it to the users, and it will work. And things that will work for the end user in the company are great. You are saving help desk costs a lot. So it totally depends on your requirements and on your scenario.
And recently, I think GitHub also made a lot of marketing about using the YubiKey. They even use it in their own house.
Yes, yes, GitHub is using it. That's right. And
is that the OTP or the Neo one?
I think they are all indeed using the U2F internally. But the interesting thing is, there are also keys that support all modes. So you can have one key and use it as a U2F device, but also as an OTP device.
No YubiKey, another.
It's a YubiKey, yeah.
Oh, okay.
Yeah. It's the YubiKey Edge. Yeah. And if you want to do PGP keys, you have to buy the YubiKey Neo. Yeah. Okay. So, so this is the interface of privacyIDEA. And yeah, before you start the bashing, I'm logging in as an administrator here. I can also configure it this way that I have to log in with 2 factors as an administrator, of course. Yeah. Okay.
You use his password philosophy, I think. Nobody has something to say.
Okay. That's bad. Okay. Yes, one of the virtual machines lost its IP address. So here I have a privacyIDEA installation, and first I can show you the users. So privacyIDEA does not manage the users itself. Usually you can do it, but usually you don't do it because, for example, you have somewhere in LDAP or whatever. I have something like an Active Directory here where I can configure, okay, my LDAP system is located there, my user objects look like this, and then I can test it and see that 7 users are located in this LDAP directory. As you can see, I can define many different user sources. So I can define my users are located here, here, and there. And then I can combine these sources into realms. I have a realm called AD and a realm def realm, and then I can see the users here. These are the users from the LDAP server. Okay. Tokens. I need tokens. Here I have a classical one-time password token. Okay, this is a classical one-time password token. I like it a lot because it has a real big display with big numbers which I can read. There are many, but this is a classical key fob token, and this is time-based, so every 60 seconds it will generate another password. But the problem, as I said, is these tokens are preseeded. So now what I have to do is I have to ask the vendor or the reseller who sold this to me, okay, please give me the keys. Then he will send me the keys and I can import it. At the moment, my system does not know any tokens. So I import the keys. There are different possible file formats. And I imported this file that contained 20 tokens. So great, now I see all the tokens that I have bought and I can start using them. But how would I start using them? I have to turn the token around and read the serial number. And you see it's a bit, I have to remember that I have to delete the file I imported or whatever. So it's a bit uncomfortable, unpleasant, because in this file there are the keys. And if I have the keys, I can calculate the one-time password without this token. 3818. It's this one here, and now I can assign this token to a user, and define also the first factor. I could also use the LDAP password as the first factor. It doesn't matter. Okay. Good. Now I see that this user has this token here. And I can test it. Ah, 205, well, it doesn't matter. 205. So I just pass my knowledge to the system, and I pass the one-time password, which represents the possession, to the system as two factors. Then I say test, and I was successfully authenticated. I can define many behaviors in the system. I think we are maybe a bit short of time, so I see that I only show some interesting things. For example, I defined a behavior here in this policy, and I said, okay, normal users can also authenticate to the web UI to do tasks on their own with their own tokens. And I said, when a user authenticates, he should authenticate against privacyIDEA. I can also say that the user should authenticate against the user store. If the user is located in an LDAP, then the user would have to enter his password to log in. This can be interesting if the system is only reachable from the local network. Then the users could log in with their LDAP password and manage their second factor to authenticate, maybe via VPN. Okay. So if the user now logs out, he can authenticate with a knowledge, with a password he knows, and with a value he generates here. So. And he logs in, the user, and the user, of course, can only see his, I don't like touchpads, he can only see his own token. The system, for example, also writes an audit log. It also logs every action that happens. And the user, of course, can only see the actions that he has done himself. An administrator can see all actions. But that's not, so we don't like this token, yeah? We don't like it, I think. So now let's enroll a YubiKey. And as I said, the coolest thing is that we can generate the key material our own. But to do this, we have to write to this device. We have to write the key to the device. To do so, we have a command line client that can be used to manage everything. I can add a file. Secrets.txt is a file. In fact, there are no secrets in it. But I can save typing command line parameters. Okay, and then I say I want to do something with token, and I want to mass enroll YubiKeys. There are many different parameters. I can initialize the YubiKey in different modes. The YubiKey has 2 slots. I can choose which slot I want to initialize. Well, I go with a standard and just say this. And then the tool realizes, oh, there's a YubiKey, and he already has initialized the YubiKey and sent the result to the privacyIDEA server. Now I could plug in the next YubiKey and plug in the next YubiKey, and this way I could easily initialize all my YubiKeys. I am done. And if I plug it in here and press the button, it emits one-time passwords. Okay. This is the representation of the device I just initialized here. This is, here you see command line enrolled. And now I want to assign this to a user. I simply assign it to the same user. Assign. And can also successfully authenticate with it. I think I prepared another scenario because I also configured this server, the SSH daemon on the server, to authenticate against privacyIDEA. So the SSH daemon is using the PAM stack. And within the PAM stack, there's a PAM module that says, okay, take the credentials you get and verify these credentials against privacyIDEA, which means privacyIDEA will check if the user authenticates successfully and let him in. So I try to SSH to the machine. I first enter my knowledge, hopefully the correct one. Then I provide my possession by inserting the YubiKey, by inserting the YubiKey and pressing the button. And as I initialize the YubiKey this way, that it will also send a carriage return, I will be logged in immediately. But only if I have the focus. Makes sense. Okay, let's try it again. Yeah, now I have here the focus in my in the login screen. Okay, and I'm logged in here at the machine.
You have to leave it in?
No, it's just the process. I don't have to leave the YubiKey plugged in. I can pull it out and I'm still logged in. It's only the moment while I'm authenticating that I need it. Yeah. In the latest version, privacyIDEA also supports U2F. This is a bit different, and the interesting thing is, this is a U2F token. I don't need to initialize the U2F token. I have to register it. So when I say now I'm the administrator, here you can see my role, I'm admin, and I can register this token for the user, for this user. And but in this scenario, no key is generated. Okay, let's start it here. I hit enroll, and then you can see the YubiKey is blinking, which means please confirm that you want to register. I have pressed the button, and you can see here that the token was successfully enrolled or registered. But the thing with this U2F token is that it's a cool hardware and it's a cool, it works in a cool manner. But again, it has a pre-seeded key, which means the vendor of the key generated a certificate and a private key for U2F on this device. There are lengthy discussions and explanations about it. I just want to drop this information that you see. There are many possibilities to authenticate, many possibilities to increase security by using a second factor. Privacy, you can manage all these possibilities with privacyIDEA, and it's up to you, or you have the possibility to decide which type of authentication device you want to use, which is the best for you. Maybe you say, all this hardware stuff, I don't like it. Then you could say and just say, okay, I don't like the hardware stuff. I enroll an HOTP-based token and let the server generate the key. And in this scenario, for example, I get the QR code to initialize my Google Authenticator. So there are many ways or many options. There's a long list of possible token types you can enroll. And so you can find the best fitting token type for you, or you can find the best fitting token types for the users, because one user can use this token type, another user can use another token type. A question?
It was related to the previous slide. When you registered your YubiKeys and the computer showed us that YubiKey is registered, I sense a potential for a weak spot here. How does computer know that the registration is successful on the part of YubiKey?
How does the computer know that
How does the computer know the fact that the registration is successful on the part of YubiKey?
Okay, how does the computer know that
This is the right
is successful, the authentic registration? The point is that the registration can only be successful if the YubiKey has done its part. So
how do we know that it does?
Same as with us.
It's a bit complicated. Roughly speaking, the YubiKey sends a so-called attestation certificate, which the server can verify. Then the server and the YubiKey makes up per registration a U2F token, invents a new key pair. And the public key of this key pair is sent to the server where the token is registered. And this is also signed by the certificate and so on and so on. So the server side can verify, first gets a public key. He also gets several handles to identify the key. And this is also signed so that the server can verify the signature. Roughly speaking. Are you content with this?
No.
Okay, no, that doesn't matter. So you're welcome. I think this is out of scope somehow, but you can read this U2F specification, which is not that fun to read, but it's roughly this way. Yeah, during registration, the key pair is generated, and the public key is sent to the server. It is cryptographically assured that the right public key arrives at the server, and during authentication, the server identifies the key that he has to use and sends a challenge to the U2F device. And the U2F device simply signs the challenge. Yeah.
So the keys are distributed towards that.
The thing is, unfortunately, this is no U2F talk. We can. You are welcome to afterwards to come and we can discuss this. Maybe you realized I'm not a complete friend of U2F because I think it's a good idea for, again, it's a good idea for certain scenarios, but not for all. And it is, in my opinion, it was designed for the end user market, and for a decentralized authentication. And if I'm talking of privacyIDEA, I'm talking of a centralized authentication. So it's a bit, it does not fit 100%. Nevertheless, again, you can list the pro and cons and see what fits you the best. Okay.
We'll just have one more question and then it's time for...
Yeah, I'm nearly done, yeah? Where was the question?
Yeah, I was wondering, can you chain multiple authentication mechanisms? That doesn't increase the two-factorness, but I could, for example, envision that you use such a key and an SMS token sent to you, so you validate that you have two devices.
So the question is if we can chain authentication. Yeah, you can do it in different ways. Either your application has to chain this. For example, when you are doing a pump stack, you can stack several modules. But there's also a thing called 4-eyes token, where you can define, doesn't matter, the 4-eyes token, where you can define that several users from several user groups should be present to authenticate. So they would really chain all their, for example, one-time passwords after each other, so that you get a 4 or 6 eyes authentication if you have an account that is so highly secure that you say only two persons need to be available when logging in.
Yeah, for example, for the admin, be privacy.
You could do this for the admin, yeah? Yeah. Okay. Anyway, to sum up, I think you saw it's the flexibility, and in your questions you also, I think I was able to show that there are many options and possibilities. It provides a simple REST API, which I haven't shown yet, but it's also documented in the documentation at Read the Docs. It is open source. It is hosted at GitHub. You can take a look at it. You can drop your issue. You can put your pull request. And I think this is a nice way to keep control, or to gain back the control about your key material, your authentication process, and finally the control on your data. And a short peek into the future. The idea is to also support the YubiKey validation protocol, and then for next year there is a German open hardware vendor, NitroKey. They are building also PGP smart cards and OTP tokens as open hardware. And we try to work together to support these Nitro keys and make these keys also manageable with privacyIDEA. And then it's always a topic to improve the packaging to make it easier to deploy. It's a Python package. It's available at the Python package index. At the moment there are packages for Ubuntu and Debian, but it would also be great to get packages for CentOS. Yeah, and these are the locations on the web. The location at GitHub, the homepage, and the documentation. And feel free to come around and look and ask questions, either now, directly afterwards, or on the mailing list. Thank you for your patience.